Okay, let's give you guys some more practice. So here, find the indefinite integral of this. So remember, you're trying to find something that when you differentiate it, it will give you this, and then and then and then and then you're trying to find something when you differentiate it, it will give you this. Okay, so press pause and have a go. Okay, so let's just concentrate on this bit here. We should make our first guess to be e to the power of something, because e to the power of something, when you differentiate it, it will be e to the power of something, and then times by the derivative of the something. So times the derivative of this something here. So this here should be our initial guess. So our initial guess should be minus 2t here. So this being our initial guess, when we differentiate it, it will give us minus 2t times with the derivative of the something here. So this will be minus 2. Okay, so tidy this up, and this will be tidy this up, and it will be minus 2e to the power of minus 2t. But then we now need to make the adjustment. So let's get rid of the minus. So if we make this adjustment here, this will get rid of the minus here. Okay, and then we want to turn this into a 4. So if we make this adjustment here, then when you differentiate it, it will give you this 4. So when you differentiate this here, it will give you 4 e to the power of minus 2t. Okay, so this here would be the answer to this bit here. Okay, so hang on. So now let's concentrate on this bit here. So our initial guess here should be sine. Our initial guess should be cos 4t. Okay, so when so this is going to be our initial guess. So let's differentiate this. It will give us minus 4 sine 4t. Okay, so this bit here is good because it matches up with this, but we don't want the minus 4. So let's make the adjustment to our original guess. So our adjustment should be minus a quarter here. Making this adjustment here would now give us sine 4t, which matches up perfectly with this. So overall the answer here will be minus 2e to the power of minus 2t, and then minus a quarter cos 4t plus c. Okay, so this here is our final answer. Okay, next one here. Okay, so find the antiderivative of this. So press pause and have a go. Okay, our initial guess here should be well, if you think about it, if you have well at the moment, let's visualize it like this. Okay, what would differentiate to give us this thing here? At the moment, visualize this thing as something over another thing here. So what will well, if you differentiate, at the moment you've got something of this form here. So if you think about it, natural log of something, when you differentiate this, it will give you 1 over this something here. Okay, concentrate on this something here. Well, anyway, our initial guess should be the natural log of this something here, because when you make this to be your initial guess, if you differentiate this, it will give you 1 over something. Okay, so concentrate on this bit here. So let's make our guess to be 5x plus 2. So when we differentiate this, it will give us 5x plus 2, and then we've got to times with the derivative of the bubble itself, which will be 5. Okay, so this being our initial guess, if you differentiate it, it will give you this. Tidy this up, it will give you 5 over 5x plus 2. Now this here is good, but we don't want the 5. We want the 2. So let's kill off the 5. Let's kill off this 5 here. So if we make this adjustment here, it would then differentiate to this. Hang on. If we kill off, if we make this adjustment here, when we differentiate the whole thing, it would give us this. It would give us it would give us yeah, it would give us one like this. But then we now want to times this by 3 in a way to get this 3 here. So we need to make the adjustment. So our adjustment should be times 3. So times 3 here, and then now it will give us this. So when you differentiate this here, it will give you this. Okay. So the overall answer here would be 3 over 5 natural log of 5x plus 2, and then plus a constant. Okay.